Hello class, I am Mr. Sutton, and today we're going to be talking about skill 1 for the second semester, which is functions. So, definition of a function, make sure you have your notes and make sure you write this down in your notes. A function is a relation of a set of inputs to a set of outputs, where each input is related to exactly one output. Couple things to note about that. Inputs are your x values, also known as your domain. Outputs are your y values, also known as your range. And the notation, we usually use f of x instead of y when we're talking about an equation. So for example of a function, so let's just say my relation is this equation. F of x is x plus 3. So let's say my input is 1. I plug 1 in for x, so that would be f of 1 equals 1 plus 3. And then I see that f of 1 equals 1 plus 3 is 4. So see how I only got one answer. So each input, in this case my input is 1, is related to exactly one output. So my output here is 4. I didn't get 4 and negative 4. I didn't get 4 and some other number. I just got 4. So that is what makes this a function. No matter what number I put in here for x, since this is a function, I'm always only going to get one output. So make sure that you have all this information down. Here are 4 ways to represent a function. We just did an equation. Graph is also probably familiar to you. Ways that are less familiar, mapping and set of points. I mean, I know we're all familiar with coordinates, but saying them as a set may be a little different. Mapping, what that is we separate our inputs and our outputs. So I'm going to say, here's my domain, and over here is my range, and we use these oval shapes and we put our domain and range inside. So, and it's called a mapping because we map each point to the corresponding, or we map each input to the corresponding output. So let's say for this relation, if my input is 1, my output is 5, and we map it using the arrows. And if my input is 2, my output is 6. And if my input is 3, my output is 4. Now notice that every single one of these inputs only went to one of the outputs. So this is a very basic example of a mapping. A set of points is when we have multiple coordinates. So let me just use this same relation I had up here. So one of my coordinates would be 1, 5. And then another one of my coordinates would be 2, 6. And then another one of my coordinates would be 3, 4. And then we just put these braces around it to show that this is one set that has 3 points in it. And these are the same relation. These tell us the same function. 1, 5, 2, 6, and 3, 4. These are just represented in 2 different ways. Okay, this is as a mapping, and this is as a set of points. And then a graph, if we do the same thing, let's go ahead and do the same relation again. So to graph this, 1, 5 would be somewhere up here, 2, 6, and then 3, 4. It looks something like this. All right. So once again, and this is a very rough graph. I didn't put any units in there, but I think we're pretty familiar with what graphs look like. And then for equation, like I said before, we use f of x instead of y. For this one, I'll have to use a different relation. So let me just go back to the example I had before, x plus 3. So this is what a function looks like as an equation. So these are the 4 different ways that you can represent a function. Make sure you have each of these down. You're able to recognize them. So now we want to look at how to tell if something is or is not a function, because you can have mappings that are not functions, and you can have mappings that are functions. So the one I showed you on the previous slide, this is a function, but it's also possible to have ones that are not functions. So let's look at this example. So remember, what we're looking for is to figure out if there's any inputs that have more than one output. Remember, our definition is the inputs relate to exactly one output. So if I look here, if I look at this relation, 0 relates to 3. So that is relating to 1. -4 over here relates to 8, and also relates to -3. So this -4 here makes this not a function. And then 6 relates to just 1, -2. So what I would say is the mapping diagram above does not represent a function because of this -4. So since there is one number in set A is the input here. We have our inputs here on the left mapping to our outputs here on the right because the arrows are going to the right. So set A, the input, where there are multiple mappings to set B, the output, is what I would say. This is where some people get confused because they see these inputs pointing to the same output and they want to say it's not a function because of that, but this is perfectly fine because each input is mapping to exactly one output. 1 maps to 2, 7 maps to only -3, and 3 maps to only -3 as well. So each one of these inputs, see how it has just a single arrow coming off of it? That means that this is a function. So mapping diagram above represents a function since for each number in set A, the input, there is only one mapping to set B, the output. So how to tell if a mapping is a function? You really only need to care about the input if each input has just one arrow coming off of it, and they can cross patterns in any way, or they can go to the same number over here, it doesn't matter. But as long as there's just one arrow coming off of it, yes, this is a function. It's not a function once like we have this 2 here. If that has multiple arrows coming off of it, then that is what makes it not a function. So it's the input that you want to focus on when looking to see if a mapping is a function. So now we want to see which set of ordered pairs, which set of points represents a function. So once again, the same thing applies. We want to look for inputs that have more than one output. Those are the ones that are not functions. So anytime we see, like, let me look for one, like here. So I have -8 goes to 4. -8 also goes to 1. That means that this is not a function because I have -8 going to 2 different outputs here. So let's go through these. Here we have 9 going to 4, -1 going to 2, -3 going to 3, and then -1 again going to -6. So this cannot be a function because I have -1 going to 2 and -1 also going to -6. Here I have -7 going to 4, 7 going to 2, 1 going to 2. This is okay. We're allowed to have two inputs. These are different inputs going to the same output. We cannot have the same input going to two different outputs. So 7 going to 2 and 1 going to 2 is fine. Negative 1 going to 2, negative 1 going to 6 is not fine. And then negative 4 going to 4. This looks like it's our function right here because I don't have any repeated inputs. This one already says not a function because we have negative 8 going to 4 and negative 8 going to 1. So let's check on this one. Negative 8 going to 9, or negative 9 goes to negative 8. 2 goes to negative 4. Negative 9 goes to 8. So here we have negative 8 and positive 8. Negative 9 going to both of those. So this is not a function. So here's the only one where each input goes to exactly one output. So here, and this tells us exactly what we're looking for. X does not repeat. So the trick for all of this is look at your X values and see if you have any repeating X values. Here we have negative 1 repeating, and then we had negative 9 repeating in this one, and negative 8 repeating in this one. So how to tell if a set of points is a function or not? If the X values do not repeat, then yes, it is a function. If the X values do repeat, then no, it is not a function. Make sure you have that in your notes. All right, now we're going to look graphically to determine whether the following graph represents a function. Same idea we've been doing. We want to see if there is any case where one input leads us to more than one output or zero outputs. Because remember, for it to be a function, each input has to go to exactly one output. So we do this by the vertical line test, which you may have heard before. So basically what the vertical line test is looking for is we want to see, is there any place I can draw a vertical line through where I touch the graph here more than once. So anywhere I draw a line through here, I'm going to just cross the line at one point. So this is a function. And oh, this gives a nice demonstration of the vertical line test. That's very cool. This one here, I can draw a vertical line through x equals 2, and I would cross here and here. So that means that when I plug in 2, I have two different outputs. I have 5, and I also have negative 5. So that means this is not a function. If I wrote this out as a set of points, I would have 2 comma 5 and 2 comma negative 5, right? So that makes this not a function because for the input 2, I have two different outputs. And let's see what this looks like here. Yeah, so once we start past negative 3, then we have two outputs for all of these until we get back to 7. That's when it just goes back to one output. So if I draw a vertical line, how to tell if a graph is a function, we use the vertical line test. If you draw a vertical line through a function, at any point, it will only pass it through one point. If you can draw a vertical line through at 2 points, then it is not a function. So this would be a function. This is not a function. How to tell if an equation is a function. You don't have any problems like this on your assignment, but I still think it's worth going over. And this is pretty simple. If you can solve an equation, so let's say you have like 5 equals x plus y. If you could solve it such that you just get y equals on one side, then it's a function. So for this one, what I would do is I would subtract x on both sides. So then I'd have negative x plus 5 equals y, and then I would just rewrite the equation with y by itself. So on the left side, so y equals negative x plus 5. So anytime you can solve your equation and just have y by itself on one side, that means that no matter what you plug in for x, then you will just have this one output. All right, that is the end of today's lesson. Make sure you have notes over all of that. If you have any questions, make sure you are going to office hours, asking your teacher for help during class. Have a good day.